Hello Year 12, this should be the last time this happens, as I'm feeling a lot better now, but I'm still signed off until Monday. So if we could try and work through these questions, they're big whiteboard questions really, but obviously you might well be at home or in the library, so can't draw on the walls. But please have a go at these 4 questions. They're on about things you've met in mechanics so far. The last topic we did on mechanics. So have a go. The Suvat equations are at the top. So if you've not got those with you, you can see them and make use of them. So I would say spend 10 minutes having a go at those 4 questions. I'm not going to hold on for 10 minutes. I'll ask you to pause this video and then have a go. So pause the video. I said pause the video in case you haven't. Okay, you've probably unpaused now, please. And if I click on them. So the first one was a particle moves along a straight line with constant acceleration of 2. The particle moves 48 meters in 5 seconds. So you chose the appropriate, you got A, S and T, chose the appropriate Suvat, put the numbers in, and you should have got the initial velocity, or initial speed was 4.6. Number 2, Suvat again. Maximum height, that's when the velocity is 0 because it stops momentarily. Number 3, and number 4, that was the vector form 1. And that was also using Newton's second law, F equals ma. So you add up the forces, because remember the resultant force is the total of the forces, and then equal them to ma, mass times acceleration. Acceleration will be a vector, but to find the magnitude of it, you'd then use Pythagoras. Okay, today, connected particles. We're going to understand and use Newton's third law, restricted to 2 perpendicular directions. We're going to be able to draw force diagrams using Newton's second law and particles separately. Sorry, for each particle separately. We're going to apply Newton's third law to solve problems involving pegs or pulleys, and to know for particles connected by a string passing over a pulley or peg, we assume that the pulley peg is smooth, which makes the tension equal on either side, and the string is light, inextensible, giving a constant acceleration. So no weight involved in the string either, or no friction. Right, I'm sort of hoping that Chris would have given you a sheet to work through with this video, so you can fill it in as you go along. So Newton's third law, what is it about? Find out in a second if it moves. Newton's third law describes the forces involved in the interaction of two objects. It states that if an object A exerts a force on object B, then object B exerts a force of equal magnitude but in the opposite direction. So if you now try slapping the wall, you'll find your hand hurts as well as the wall because the wall's hit back. So that's what meant by it. So only you're being hurt and the wall's being hurt. So they're both pushing at each other. A light inextensible string is a string with negligible mass and is capable of being, incapable of being, and the word there will be stretched because it's not like an elastic. A smooth fixed pulley is fixed over a smooth fixed pulley is a fixed wheel over which a string is passed, like in this diagram. There is no friction between the string and the pulley because it's smooth. The tension in a light inextensible string which passes over a smooth fixed pulley is constant. So what we're saying here, this tension equals this tension here. They are the same number of newtons because it's a forces tension. Have a vote now. So you have to be sat on your own and go for one of these options. Two identical objects are connected to Two identical objects are connected to ends of a light inelastic string which passes over a smooth pulley. What happens if the system is released from rest? So there's a picture of what's happening. We've got our string going over the pulley and 100 gram weight on both ends of both strings. What do you think happens if it's released from rest? Is it A, the masses move to a level position, the masses remain at rest, the lower mass accelerates down, or the higher mass accelerates down? Have a little think and decide which one you're going for, A, B, C or D. Right, moment of truth. Not sure how many you'll have voted for this one. I bet not many. The answer is B. The masses remain at rest because the tension in the strings as they're going over the pulley, as I said, are exactly the same. So tension 1 and tension 2 will be the same number. These two things weigh the same. So the tension on this block and the tension on that block is exactly the same. So therefore they won't actually move at all. They'll remain at rest. Give yourself a little round of applause if you got that correct. And if not, you won't be the only one. I would show you a demo, but can't really. Right, example 1 here. The diagram shows two particles. Hello squirrel, cat's arrived. A has mass 4 kilograms, whilst B still has mass of 3 kilograms. They are connected by a string which runs over a fixed pulley. What happens when they are released from rest? Find the acceleration and the tension on each particle. Well, this time they're not equal, so it will move, and the heavier weight will come, obviously, go downwards. So acceleration will end up going this way, so it's always good to get an acceleration arrow on there so we know which way we're modelling. So here we can say that A has the greater mass, so that will accelerate down. The particles join together, so the magnitude of acceleration is the same for B, but in the opposite direction. The B will go up. So acceleration's showing there. To find the values of A and T, we use Newton's second law on each particle separately. So I'll go for A, modelling A downwards, and then I'll go for B, modelling B upwards. So what's happening here for A, modelling it down, so 4G is helping it go down, so modelling that one, so 4G will be positive, minus the tension will equal mass times acceleration. And here, this weight is in, it's not grams, is it? That's for gravity. Let's be careful there, because that's 4 kilograms. So that's why it's written as the force 4G, 4 times gravity, and 3 kilograms, and it was written as the force 3 times gravity. So mass is 4 times acceleration. And the next one, if we look at B, to help that one go forwards, because it's going up, T will be positive, and the thing 3G bringing it down, and that equals 3 times acceleration. Acceleration being the same for both things, and tension being the same in both string. Well, not both strings, the same string. Right, so we've got our two equations. To solve these, we could do them by hand by adding equation 1 plus equation 2. That would give me 4 plus minus 3, which gives me 1G. Adding those, I'll get 7A. And then I know that G is 9.8. So that means 9.8 times 1, 9.8 equals 7A. Therefore, A will equal 1.4 meters per second squared. And if you sub that back into equation 1 or 2, I'll put it in 2, then we'd get T minus 3 lots of 1.4, oops, sorry, no, not 1.4, that's 9.8, 3 lots of 9.8 equals 3 times 1.4, rearrange that around and you'll get 33.6 newtons. Now you could also do this on your calculator, as I'm showing, I hope. If I can show, it might appear in your video, I hope so. You go to equations mode on the menu, pick simultaneous, 2 unknowns. How you have to put this in, oops, it's gone again. is the unknown plus the unknown equals the constant. So 4g is known, that's just 4 times 9.8, so that's my constant. So if I take the t's over the other side, I'd have 4a plus 1t equals 4 times 9.8. And on the other side, I've got 3a's. I have minus a t. And that equals, because I brought that over here, negative 3 times 9.8. I'm pressing exe again. As you can see here, hopefully you can see that if I done, you get A is 1.4, and that's the first entry, and the second entry, which would be our t value, is 33.6. Hope that shows in the video. Note, if asked, the force on the pulley is due to the string is alright, I see what you're saying. No, they've asked what's the force on the pulley, so we're looking at what forces are on that pulley here. What forces are acting on this pulley? Well, there's a tension there and a tension there, so the forces acting on the pulley is 2t, if you were asked. 2 times tension, which in this case will be 2 times 33.6. So, example 2. The diagram shows 2 equal scale pans, A and B, each of mass 200 grams, connected by a light inelastic string hanging over a smooth pulley. A pebble, C, of mass 300 grams, is placed in B, and the system starts to move. Find the acceleration of the system. Okay. Well, obviously B is going to come down and A is going to go up. So if we put that on, just to help our brains, it's going to accelerate that way. This one's going to accelerate this way. The tensions in the string will be identical, so that tension there and a tension here, but this weight will be pulling this one down, and that one. Now it is grams this time, so 200 grams for each, so that's 0.2 kg, isn't it? So it'd be 0.2 kg but times gravity. And this time over here we've got 0.2 and we've got 500 grams still together, so I've got 0.5 times gravity. Right, I'll use Newton's second law and forces. So the forces acting on A, tension's going to be positive, it's going up, and the other force, the weight force, negative, and that's going to equal mass times acceleration. Mass times acceleration. And the other one, the B and C together, well, that one, this time the weight's pulling it in the direction it's going, so that's positive. tension's acting against it, and the mass of all that lot. Right, we can solve those on the calculator. And I think the way I showed you last time didn't show up the calculator. I'm very sorry, but we're in equations mode. Simultaneous F1, F2, sorry, F1 again for two unknowns, and we'll enter them in as, remember the unknowns are the A and the T. G is 9.8, so we'll enter this one as 1T and 0.2 and equals 0.2 times 9.8, and the equation underneath, I put T in first, so I need to put T in again first, so I have to put -1, then enter, and then minus 0.5, enter, and the 0.5g goes over the other side, that's another minus, so that's minus 0.5 times 9.8. So this time, oops, I think I've put something in wrong here. 1 negative, yeah, positive. And then -1. I don't seem to like that. I'm going to do it by hand. Don't know what's gone wrong. So if what would I do with these? I'd add them, wouldn't I, to get rid of the T's. So if I add them, I get 0.3g equals 0.7a. And then I know what g is, that's 9.8. So with g equal to 9.8, 9.8 times 0.3 divided by 0.7. Comes out at 4.2. So A is 4.2. If you want acceleration, tension, you can just put it back into the equation. Well, that solving equation should have worked for you. I don't know what's wrong with my machine. Must be something a bit dodgy. Oh, there was a part B. It said we'd also got to find the reaction on B due to C. Ooh. Newton's third law here. When two bodies interact, the force on each due to the other has the same magnitude but in the opposite direction. So the pebble's pushing on the pan and the pan's pushing back. So drawing the forces acting on the pebble. Right, so just the forces on the pebble. The pan's pushing back, so that's your R force. And then there's the weight of the pebble, which is pushing on the pan. So what I'll call that weight of the pebble pushing on the pan is 0.3g. That's going down, so that's positive. Pushing back up, so it'd be minus R. And this equals mass times acceleration, but this pebble is sat on the pan. It's not moving anywhere. So that will be 0.3 times acceleration. But I said acceleration was going to be 0 because it wasn't going anywhere. But it actually isn't not going anywhere because this thing's in motion, isn't it? this thing's in motion at an acceleration of 4.2. So 4.2 downwards, that's positive 4.2. So it's going to be mass times 4.2. And therefore we can work out the reaction force by working out all that. So we've got 0.3 times 9.8 minus 0.3 times 4.2 equals R. Put that in your calculator and R works out to be 1.68 newtons downwards. Right, try this one. Particles of mass 3 kilograms and 7 kilograms are attached to each end of a light, inextensible string which passes over a smooth pulley. The system is released from rest. Find the acceleration of the system and find the tension of the string. If you need the diagram to get you started, there you go. I'm going to pause the video now and give it a good go. Okay, if you're ready to look and you've unpaused the video, here we are. That's F equals ma on both particles. If you solve those simultaneously, you'll end up with the acceleration being 3.92 and the tension 41.2. Well, I hope you're successful and you'll try this one as well. Here you go. Pause the video and have a look. I'll draw a picture while you're having a go. Okay, do make sure you pause this video till you're ready, and then here comes the answer. Oops, drawn all over it again. I must rub that out. Better diagram the blue one, I think. There we go. One more to have a go at. Really do pause the video and try this one. Okay, you've unpaused now. There's the picture you'll have drawn, and they're working out. And this time you had to find the acceleration, and then you needed to use SUVAT to find the distance travelled. Hope you got that one. So you used Newton's second law here, F equals ma. Find your tension and your acceleration with simultaneous equations, and then to find how far it had travelled, use the appropriate SUVAT equation for what you know. Started at rest. There's the acceleration. Time took 2 seconds, so you'd use that one and get 4.8. Well, there's another here. It's another one for you. Have a go. Pause the video. You want some questions though? There, that'll help. Please pause. Okay, unpaused. So similar idea, what was going on. Putting all the forces on. Using Newton's second law, you can find T and A with your calculator and simultaneous equations. And A works out at 2.8. It also gives you tension, but it doesn't ask for it. Well, your calculator gives you tension as well. Right, it's part B now. Find the magnitude of the tension in the string. Oh yeah, I was going to say the calculator's done that as well, hasn't it then? So substitute that back in if it's not. Well, you would have got on your machine. The tension worked out to be 6.3. So it's just part C we haven't done. The magnitude of the force of the pulley due to the particles. So the magnitude of the force on the pulley due to the particles. So what forces are on the pulley? Mentioned this one before, can you remember? Yeah, forces on the pulley is 2T, which in this case is 12.6 newtons. Okay, that's the exercise questions you're going to do in a moment, but before you do those, and those are the ones I want you to write down on paper and submit to show that you've done this homework. That's in the textbook, Cambridge Go textbook. I might do you a copy of that to make sure you do it, but I want you to submit those to prove to me that you've understood today's lesson, and to prove to yourself you've understood today's lesson. But you might want to try this one before you get on with that exercise. Here's an exam question. It's worth quite a lot of marks, 10 marks, so I'd give it 10 minutes. 10 minutes only. Pause this video and have a go. Okay, hopefully you've on pause now. You've had a good time on this, good 10 minutes. First thing I would suggest you did was a diagram with what's going on here. Then draw your, well, do your 2 Newton's laws on particle, well, whatever it is, particles P and Q. And if we just use the first equation for P and get the answer to the tension, now if I sub that in, that might help me find the value of M. I've called it X here, but it's the same thing. And then part C said calculate the speed, so we're now in SUVAT. Starts from rest, so it was 0. What's phi? So use an equator appropriate equation. And finally was calculate the greatest height of the particle above the surface. And you can assume that P doesn't reach the bullet. So you're modelling P, how far up does it go? So in other words, what's the S? You know that U is 0.84 from the last question. The maximum height, well, its velocity will stop. And acceleration due to gravity is minus 9.8. So using SUVAT gave 0.756. Well done if you got it. Right, so that's the end of the lesson. I want you to have a go at those questions now. If you like, you could see the mark scheme for that, but you need to have a go at those questions that I mentioned from the exercise book. And yep, I'll see you next week. Make sure you submit everything, please, and hopefully Chris gave you the notes so you were able to make them as you went along. Another one of those things for you to vote for if you wish. 2 objects resting on a smooth table connected by a smooth pulley which is dragged in a direction as shown. What happens to the system? The masses move together and stay level. The larger mass remains at rest and the smaller one moves. The larger mass moves faster than the smaller one, and the smaller mass moves faster than the larger one. And the tension will be the same in both strings. What do you think? This one's probably more obvious. Have a quick guess. And there we are. Did you guess correct? The smaller mass will move faster forward because the mass is smaller. So obviously tension, which will be the same in each string, divided by mass, which is smaller. So let's say the tension was 10 newtons in both strings. I've put 5 now. Let's put 50 newtons in both strings. Then the acceleration of the little block, because doing F equals ma, will be the force, which is 50, going forwards, divided by divided by the mass, which is 1 kilogram, equals acceleration. And in this case you'd have the same force divided by the mass, which is 2 acceleration, so that one's moving obviously faster. Right, I'll be quiet and let you get on. Bye bye.